probability video, we're going to start talking about figuring out how many options we have if order does not matter here. So we talked about permutations last time where order does matter. Now we're going to get into where order does not matter. So Wendy's had a takeout bag a few years ago that said there are 256 ways to personalize a Wendy's hamburger. Luckily, someone's paying attention to math class, so we're going to analyze that. So first, does the order of toppings matter? So is ketchup first, then mustard the same as mustard and then ketchup? So yeah, kind of. If you put on ketchup first and then mustard, it really doesn't matter. It's going to taste the same. So order does not matter. Order does not matter. The hamburger will taste the same no matter what order you put ingredients on the burger. So you're going to choose your 3 favorite toppings, list all the ways they can be put in order below. So let's just say you like, ketchup and tomatoes and pickles. So you can have ketchup, tomatoes, and pickles. You can have ketchup, pickles, tomatoes. You can start with pickles, put ketchup and tomatoes. You can put pickles, tomatoes, and ketchup. And then you can start with tomatoes, pickles, ketchup, or tomatoes, ketchup, pickles. I don't think there's any other ways. So it looks like there's 6 different ways that we can put those 3 toppings on in the same order. So that's like if we had those 3 options and we put one of the 3 on and then one of the remaining 2 on and then the final one on, that would be like 3 factorial. And 3 times 2 times 1 would give us 6. So we can order 3 toppings, 3 factorial ways. So how many ways can we order a hamburger with 3 toppings if the order does not matter? And that's assuming that we have a total of 9 topping options. So if we have those 9 topping options, then we would have, and we chose 3 of them, we would choose 1, and then we'd choose a second one, and then we'd choose a third one, and we'd have 9 times 8 times 7. But we saw that we can order them 3 factorial ways where it would be the same. We just, mix around the order. So we don't want to count all of those. So we're going to end up dividing by that 3 factorial. And what this ends up being is that top 9 times 8 times 7, that is 9 permutation where we're choosing 3. That's from before where we're choosing 3 out of 9, but we don't want any repeats. We don't want ketchup, tomato, pickles, ketchup, pickles, tomatoes. We don't want any of those repeated ways that we just saw there. So that would end up getting us, that's over 6. And then we pull up our calculator. 9 times 8 times 7 is 504. And then we divide that by 6. This ends up getting us a much smaller number because we're taking out all of those repeats, all of those extra different ways that we can have them. And it's not just these 6 here. It's the 6 that come from topping A, B, and C, the 6 that come from topping D, E, and F, the 6 that from topping B, D, and F, etc. So all those different variations that we can have of the 3 toppings, we're eliminating the 6 combinations that are the same grouping of those toppings. So when order does not matter, here, let's write this in a text. When order does not matter, the number of combinations that we're going to have is smaller because we're eliminating all of those repeated values, those repeated ways. So to summarize what we did here, we did up top here, we had, to summarize what we did here, we had 9 toppings and we chose 3. We eliminate the repeats. And what this actually ended up equaling was something called a combination, where we have 9 and we're choosing 3 where the order does not matter. So we're gonna, as my dog starts barking at the lawnmower guys outside, we're gonna go through all these, and no matter what number of toppings we have. So for example, here we have 0 toppings. So how many different ways can we order that? We're gonna have 9 choose 0. And how many different ways can we choose 0? Well, there's only gonna be 1. And then we're gonna have 9 choose 1, 9 choose 2, 9 choosing 3, 9 choosing 4. And I'll let you explore this on your calculator, how to calculate these. I'll have a separate video for showing permutations, factorial, and combinations on your calculator. So how many different ways can we order these by choosing all these toppings? What we'll see is that when we add up all these different variations, we're going to end up with 512 different ways to order a hamburger. So they kind of undersold it at the beginning when they said that there were 256 ways to order hamburgers. They're a little bit off, but not too far. They just need to double it, apparently. So we'll wrap up with our important ideas from the text. And we're going to start with combinations. So combination is the number of ways we can choose a group where order does not matter. And so just like permutations, we got a little like formula that we're going to use there. So it'll be n and then choosing x, where that n is going to be like the total number of items that we have to choose from. And then x is going to be the number of items you choose. And again, order does not matter there. Let's get back to our vertical shape. A straight line there. And then one last thing before my dog goes crazy at the landscapers is going to be probability, which we'll need for down below, I believe, number 3, is we can use, either permutations or combinations, whatever whatever the situation calls for, to determine the total number and then the number we want to select from that. So you'll see when you're working on number 3, you want the probability that none of the 8 songs is by One Direction. You'll take all of the songs possible and then figure out combinations that don't have the songs of One Direction, and you'll divide those and get a decimal there or a percentage. All right, so I'm gonna make another video right after this showing you how to do this on the TI calculators, combinations, permutations, and factorials. And then you should be able to finish this application, which should be called Check for Understandings, but that's okay. Just a few questions here, and then your teacher should have a math Excel for you.